Okay, are we good to start? Okay, hello. This is kind of a two-part presentation because we don't know the makeup of the audience. So I'm going to poll you guys for kind of what I need to explain and what I don't. And depending on how it goes, I might disappear immediately. So we'll start off. Does everyone here know, like, who here knows how, like, roll-ups work? Kind of. Okay, cool. I will try to start from the beginning but talk super fast, because we are super intense on time. So we have building on Scroll today. We're talking about the intro to Scroll as well as exploring L1SLOAD. We do a lot of internal research. So today's bounties that we'll be doing kind of covers both sides. So I'm going to start off with like the basics, right? Like, what are rollups? Well, why do we even have them? Ethereum is fucking slow and expensive, right? Exactly why? We're going to talk about the blockchain trilemma. So basically, it's a pick two situation between scalability, security, and decentralization, right? You can't have all three together. So what do? I mean, ultimately, at the end of the day, Ethereum's like principles are security and decentralization. So how do we solve that? And so that's where L2s come in. So L2s are basically, what they do is we take the execution off chain, right? So rather than having to do all that expensive compute on Ethereum, we actually do it in a separate network, which is the L2. It's called a rollup because we basically roll up all these other transactions and then post them to Ethereum. What that means here, I specifically specify here, is data availability. So we inherit the security and decentralization of Ethereum because all of that data gets posted back. So I think another thing that I want to clear about a lot that I think people get confused about is if you know Polygon proof of stake is a scaling solution. It is not a layer 2. And it is specifically because they don't post their data back to Ethereum. So that's like an important thing to kind of differentiate. Now we dive into like the different types of rollups. So in kind of the history of rollups, you might have heard of optimistic rollups. So they're kind of the ones who came first. And they differentiate themselves basically on how they prove. So when we post that data back to Ethereum, we want to verify that it's true. We can't just like post random shit, right? So what that looks like is with a fraud proof, we just optimistically assume that it's true. There's like crypto economic incentives that basically make it like so that you don't want it to not be true. But what that means is we have, like, I guess, something called the challenge period, right? So we need to set aside time for people to come and say, hey, that looks kind of strange, let's do a fraud proof, and then actually check whether or not this is correct or false, right? So what this means is we have, like, what we could say, like, slower finality being, like, it's time to finalize on the L1. Right? Which also means withdrawal times or so. Withdrawal means pulling from the L1, so getting your funds out, right? So there's like a little bit of liquidity fragmentation. If you've interacted with rollups, you probably actually don't experience that because you're using third-party trusted bridges to basically give the feeling of instant finality. But obviously we know, well, hopefully you know, bridges have been, I think, the major hacking point that we've touched. So anyways, that was the first iteration. What's the next iteration? We talk about zk proofs, right? So instead of proving, like having a challenge period, let's be proactive about it. Let's mathematically prove this first and then submit the proof of verification first. The other thing that I always like to note here as well is with zk proofs, people often think privacy. With zk, we don't use it for privacy, we use it for scaling. And what that means specifically is proofs. zk proofs have the smallest amount of data that we can post back. What makes a rollup expensive is that data size that we're posting back, as well as like the verification compute time. But anyways, so that's the quick overview. And now we're gonna dive into a little bit about like, okay, wow, there's so many zk rollups, how do we decide between all of them, right? So if you're not familiar with the different types of zkEVMs, basically, there's 4 different types, zkEVMs being at a very high level kind of the way you translate code into math in order to make it provable, right? So type 4 is going to be the farthest away from a zkEVM, or like a pure EVM. So what that looks like is a zk sync or a starknet. What that means for you as a developer, it's high-level language equivalent. It is not bytecode equivalent. So you're going to have to download plugins. It's not going to look exactly the same. We can kind of scroll down to type 2, so that's kind of where scroll sits. We are bytecode equivalent, so what that means is, you know, it compiles down the same, your precompiles, opcodes are covered. It should feel, developer experience-wise, exactly the same. So normally you deploy, you're like, oh, my network is Sepolia. You literally just switch the words to say scroll, and it should work, right? And then type 1 is going to be Ethereum equivalence. Basically, the main difference here is like the way state is hashed and stored is a little different. But for the most part, as a developer, type 2 is kind of the seamless experience that you'll get. The trade-offs here are going to be like type 4 because you're the farthest away. It is easier to be faster and cheaper, whereas type 1 is going to be like the hardest to become fast and cheap. But that being said, technology is ever moving, and I think the assertion that a type 4 will always be faster and cheaper is not necessarily true. So anyways, move on. We talk about scroll. How does it fit into the picture? I don't know how much time we have left, so I'm going to talk about this really fast. So like I said, we are EVM compatible. We're type 2. What that means is we leverage the network effects of Ethereum. Oh, we have 5 minutes. Shit, okay. We have 10 minutes. Oh God. We're secured by zk proofs. I think the other thing that I want to touch about was security, especially when you think about bytecode compatibility. How many of you guys are familiar with the Viper hack? Nobody. Okay, so basically, Viper, right, is a high-level language, right? So you can write smart contracts in Viper. What happened was, I don't remember which protocol, but they lost a bunch of money. And why was it? It wasn't because the code, smart contract code had a bug. The Viper language itself, the compilation had a bug, right? So that's not like something you can really protect yourself from. So when I talk about like bytecode equivalence, I think something I also like to think about when it comes to like a type 2 is because it mimics the behavior of Ethereum, like the EVM, like you have that additional level of security that you wouldn't otherwise, because from a smart contract auditor point of view, the farther you are away, the more kind of layers you have to think about, which could potentially open up more attack vectors. Anyways, so scroll is this. So we talk about, I think someone always asks me like, okay, there's so many roll-ups, what are we thinking about? The spicy answer is tech doesn't matter, ecosystem is the only thing that is there, right? I don't necessarily think that's true. I think it's a marriage of the both, but if we're gonna talk about what Scroll looks like on the ecosystem side, I think we'll talk about grants a little later if you want, but I think we're really focused on like definitely like supporting builders, like a lot of one-on-one interactions. What I say when someone is thinking about like where do I want to build, the things that you should think about for a chain is longevity and legitimacy. So there's a lot of different like technology coming out. Is what you're building on going to last? In Scroll, we have like a really strong name. And so yeah, the other thing is I think we have a really great support for emerging markets. So if any of you guys are from there, please talk to me. I want to figure out how to help build your community. Anyways, growth is insane. Those are big numbers. Anyways, so that was the part 1 to the deploy kind of casual. I think we're going to dive into, like I said, Scroll's really heavy on the research side. You have a question, we can talk afterwards. Daniel is going to come up and talk about something really cool called L1SLOAD that you guys could also potentially hack on.
All right, thank you, Emily. I don't have quite Emily's energy, but we'll get into this anyways. Cool, so that's the background on Scroll. I'm going to talk to you about something that we have only on our DevNet. So we have our Sepolia testnet that you can hack on for the hackathon. For this hackathon, we also have a DevNet that has a special feature called L1SLOAD. Going to be a little bit lower level probably, but we're going to dive in here. The idea is that we want to have a contract, we want L2 contracts to be able to directly read L1 state, okay? That's about it. And we're going to look at like why that's maybe valuable, why that's interesting, how to use it. And it's something we're introducing to try to get all the rollups in the ecosystem to align around, because we need this to be a standard across L2 ecosystems. So why? Well, there's plenty of reasons to read L2 or from L1 into L2. There's a lot of value in the Ethereum storage slots, right? It has the best security and decentralization guarantees. It is a kind of politically common ground, but amongst all these L2s, has a lot of credible neutrality. It's the default for protocols and also like past activity on Ethereum. There's lots of valuable and interesting data there, both on Sepolia and mainnet. And every rollup has a canonical bridge that finalizes its state there. What that means is the state root contains a lot of information that you can extract out of it. And if that's sitting on the L1, you can start reading about other L2s from your L2 by getting that off of the L1. We'll kind of see that a little bit, but I think we'll have to push to have some conversations outside as well. One thing that we've been looking at for this is the key store. The idea here is that your verification logic for your smart contracts can live on the L1, and you're able to reference it from all your smart contracts on the L2. Think, oh, data on L1 is expensive though. We've been kind of like working on a proposal where you read it off the L1, but you can delegate to update it from any of these L2s. Also happy to talk about this at any point. This weekend I'll be around. Why are we doing this? Because direct reading from the keys from the L1 is like way easier and cheaper for users, and there's a lot less infra work required for app developers, wallet developers, or anything else. There's lots of other ways to prove state, including all these paths here, but they're complicated, they're burdensome, and instead, we get to do something like this as smart contract developers. This is a full contract that will read from from the L1. You pass it your contract address, you pass it the storage slots in that contract, and it will return that back to your contract so you can use it for whatever you need to. We'll talk about some of those use cases. So this is the crux of it here. You pass it the precompile address, you make a static call to that, and you pass it the arguments. Cool, I skipped a few slides. One kind of interesting demo that we did last month in Berlin was we worked with the Safe team to where if I have a Safe wallet on the L2, it will read the signers and how many signers are necessary from an L1. So that way, if we have a treasury on L1, it's being managed by some folks. Every time that gets updated, I don't have to go to every L2 and update the list of signers and go ask everyone to go do additional signatures. Like all of this stuff can now become seamless cross-chain. So that's kind of one of the things that this unlocks. But when you start doing cross-chain stuff, it might get complicated. We might be doing Merkle trees. We might be calling ETHGetProof RPC methods. You might have to deal with like Scroll's zkTry and our zkTry verifier. So there are resources that you'll have to dive into if you want to get really complicated with these architectures, but you could also just read a storage slot. You can read the name of a ERC20 token or something else. And I'm happy to like sit down at our booth and kind of walk through some of these resources if the documentation that we've provided doesn't get you there. What does this enable? Well, we can now have trustless cross-chain coordination. This is something that's like not necessarily possible using the other kind of tools and bridges that you're imagining that are accessible to devs. We can start building asynchronous composability. We can do things like the key store. We can have ecosystem agnostic minimal rollups. That's a mouthful, but the idea is that you can devote just a really simple rollup to doing one behavior and then just utilize that from other chains. We can think about bootstrapping new rollups by reading from L1 Oracle data into the L2s. We can think about verifying asset or NFT ownership from a different network because oftentimes people want to keep their NFTs on the L1. And then if you want to get really fancy, you can think about using L2s to do the zk verifiers and coprocessors for L1 protocols and then bridge the state back and forth. There's lots of design room here when you're thinking about the patterns and architectures for your hack, and we would love to see all sorts of wild and crazy ones. For me, the weirder the better. We have introduced this as an RIP to the ecosystem. We're looking for feedback, so if you're also like on deeper into the research side or just have comments on how it worked, please give us feedback on this in the Fellowship of Ethereum Magicians. And help us iterate on it. For rollups in ecosystems, we really want people to either get behind the RIP or give us reasons why they won't be able to implement it. But for app devs, it's more about testing, ideation feedback, and for hackers here, we have 2 prizes at $2,000 each. And remember, you can just read any state from Sepolia. So if all your hack project is on Sepolia and you find an interesting reason to like pull that into an L2, make it happen. So this QR code will get you to a kind of hacker resource page with information on our prizes. There's a link to both a Telegram bot that has a faucet for the DevNet and for Scroll Sepolia. And there's also a link to what we call a hackathon cheat sheet that should tell you all sorts of different projects that Scroll Sepolia supports. So if you're looking to hack on 3 or 4 sponsors at a time, Scroll Sepolia is a good option for that as well. You wanting to wrap this up, or should I take the rest of these slides? Cool.
You're good at reading slides.
All right, wrap it up here. So, Hag with us, we've got 10K in prizes. I already told you about the L1SLOAD ones, but additionally, we have Best Project on Scroll. How much was L1SLOAD? 4,000? That means there's a remaining 6,000 for Best Projects on Scroll. I don't remember, I think we have a winner and 2 runners up, maybe?
Yeah.
So, that can be on L1SLOAD or not. We're just looking for creative projects, weird projects, innovative projects, technically wild projects, or just really good applications and use cases for problems that you kind of see in your own life. So we also have a brand new grants program. There's plenty more information here, but we have a deadline on August 7th. So if you're a builder looking for funding, either you're just kind of getting started or you're needing support to get your project to that next level and really get it launched, check this out. We have up to $10,000 on one track and $100,000 on another, and we'd love to have you building with us, building with Scroll. Thank you, and this is a QR code again for the ECC URL. One more thing.
2 minutes. Read the requirements. You have to deploy and verify. Just so you know, this is my hackathon advice for winning any hackathon. Because people don't, and then they get disqualified.
Contract address in the GitHub, verified on the Explorer.
Yeah.
Always a good thing.
It's so easy.
I guess we have 1 minute. Any questions?
A question about ETH equivalence. So do you have block hash thing on Scroll? Can you repeat the question?
The question is, do we have block hashes on Scroll? Do you mean every single block, is there a block hash that represents the header?
There is a function in Solidity that returns the hash of a block, and I know that on zk there are sometimes challenges with hashes.
Yes, there are challenges with that, but I can't give you off the top of my head the actual answer to it, so I'm going to show you where to self-service, which is on the developers area of our documentation. You can see that block hash returns, so basically it's not a proper block hash, but it is a value representing the block that is going to be unique to the chain. So, yep. Cool. Thanks everyone for your time. Appreciate it.